Good morning, friends. Now, the next numerical of illustration that is depends on the damped oscillation. Frequently, this type of the numerical are asked. Right? Already we know that in damped oscillation, the amplitude of the oscillation is continuously decreases with time. And also, we derive the equation of mechanical energy. Mechanical energy of a oscillator is depends on the amplitude. Here in damped oscillator, amplitude is decreases with time, therefore the mechanical energy is also decreases with time. On the base of this, we have to calculate this numerical. For a damped oscillator, the mass of a block is given the 200 gram and force constant is given 90 Newton per meter, and damping constant B is given the 40 gram per second. So calculate the time period of oscillation. What is the periodic time of damped oscillation? Second, the time taken for its amplitude of oscillation to drop to half of its initial value. Right? That means we have to find out the time for which the amplitude becomes the half of its initial amplitude. And next we have to find out the time taken for its mechanical energy to drop to half of its initial value. Clear? We have to calculate this. So first we note down whatever the data is given. The mass is given. Therefore, M is equal to 200 gram. That means the 0.2 kg. Now, first constant K is given 90 Newton per meter. And the damped coefficient B is given as 40 gram per second, converted into MK 0.4 kg per second. That is the value of B. First, we have to calculate the time period of oscillation So we know that periodic time T is equal to 2 pi under root of M upon K. Because the M and K are given, therefore 2 into 3.14 into under root of M. M is 0.2, K is 9, 0.2 by 9. So simplified, we get the answer is 0.296 second. 296 second. That means approximate 0.3 second. So we know the equation of periodic time T is equal to 2 pi under root of M upon Q. Therefore, the answer is 0.296 second. Now the B part. We have to find out the time for which the amplitude becomes the half of its initial value. For that purpose, we can add the displacement of the oscillator at time t. Now, displacement of damped oscillator at time t is, there is the xt is equal to, we know the equation A cos omega t plus phi, but here there is the A is to minus bt upon 12 into cos omega dash t plus phi. Omega dash t plus phi. Now at time t is equal to 0 and initial phase phi is equal to 0, cos omega dash t plus phi is equal to 1. Therefore, xt, or there is the amplitude at, or the dash t is equal to A is to minus bt upon 12. Now we assume, suppose at time t dash or the t is equal to tau half, the amplitude becomes the half of its initial value. A is the initial amplitude and that is at time t. What is the amplitude of damped oscillation? suppose at t is equal to t half time, amplitude a dash t becomes the a by 2. Therefore, a by 2 is equal to a is to minus bt half upon 2a. A cancel. Therefore, 1 by 2. Here the power is negative, so we can add like this: a is to minus bt half upon 2a. We compare the denominator term. Therefore, 2 is equal to e is to bt half upon 2a. Taken. Take ln on both sides. Therefore, ln 2 is equal to bt half upon 2m into ln. Now listen, what is the difference between the ln and log law? ln and log law. In log law, base is 10. In ln, the base is e. Base is e. Now we have the log table on the base of 10 base, log base, not on ln base. Therefore, here we have convert this ln 2 into the log 2. Okay, we discuss later. Now, ln e is equal to 1. Therefore, ln 2 is equal to b into t half upon 2m. We require the t half is equal to 2m into ln 2. Now listen, to convert the ln into log, so we have to multiply by 2.303 into log log. There is a standard equation already you are using in chemistry, right? So this way we convert the ln into log. Therefore, 2 m is given. What is the value of m? 200 gram. That means the 0.2. Now 2.303 log 2. Log 2.3010. In natural log, in log, what is the value of 20 versus 0? So that is the 0.4 into 2.303 into 0.3010. So the time to becomes the amplitude, half of its initial value is 6.93 seconds. Now, clear this? Again, the displacement of a tapped oscillator at time t is this. Or directly you can add this equation. The amplitude of damped oscillator at time t, a dash t is equal to a raised to minus bt upon 12. Suppose at time t is equal to tau half, the a dash t becomes the a by 2. A is the initial amplitude. Therefore, a by 2 is equal to a is to minus b. Instead of the t, we substitute t half upon 12. Therefore, a is cancelled on both sides. Therefore, half is equal to 1 upon a is to b t half upon 2m. Right? Compare the denominator term. Therefore, 2 is equal to e is to b t half upon 2m. Take ln 1 both sides. Therefore, ln 2 here. As we take the ln from the laws of logarithm, this power is in multiplication of this log term. Ln e, here the base e is silent, therefore ln e upon e, or the e base e, its value is 1. Therefore, ln 2 is equal to b tau half upon 2m. We require this value, therefore tau half is equal to m into ln 2. How we convert the ln 2 into log? So ln is equal to 2.303 into log. Whatever the value of the function here. So here the 2. Therefore first 2. Now m is 0.2. ln 2, that means the 2.303 and log to this value. Log 2 from table 0.3010. So as we simplify, we obtain the 6.93. Now the third part, the mechanical energy. Mechanical energy time t is Et is equal to E0 EH2 minus Bt upon M. Minus Bt upon M. Clear? Suppose that, now the same method of this. Suppose at t is equal to tau half time, Et becomes the E0 by 2. Substitute in this, therefore E0 by 2 is equal to E0 EH2 minus Bt upon 12. E0 E0 cancel. Therefore 1 upon 2 is equal to 1 upon EH2. Bt half upon M. Compare the denominator. So 2 is equal to EH2 Bt half upon M. Take ln on both sides. Take ln on both sides. So we obtain ln 2 is equal to B tau half upon M. We are interested to find out the tau half. Therefore, tau half is equal to M into ln 2 upon B. ln 2 upon B here also. Now M is given at 0.2. Here 2.303 log 2 upon B. Therefore, there is a 0.2 into 2.303 into 0.3010 upon. Value of the B is 0.4. Value of the B is 0.4. Therefore, we obtain the answer is 3.04. 3.405 seconds. So in this time, the mechanical energy becomes half, while in this time, the amplitude of damped oscillation becomes the half. Here it is. Now listen here. The importance of the equation is that in this equation, in denominator, the 2 is not present, while in this equation, the 2 is present. Only the difference is there. And due to that reason, here the time becomes the double half of this value. The same numerical also asked, numerical value I think this numerical is for Hoover. For a damped oscillator, the mass of the block is, instead of the 400 gram, so here 200 gram, 400 gram is given. 400 gram is given. And force constant, instead of the 90, 120 Newton per meter. 120 Newton per meter. And damped coefficient, instead of the 40, now 50 gram per second. 50 gram per second. Find out the same quantity. Find out the same quantity. Now answer are for A. A is equal to 0.36 seconds. Check it yourself. Answer of periodic time T is equal to 0.3 seconds. Answer of the B. That means the time for which the amplitude becomes the half of its initial value. There is 11 seconds. Tau half is equal to 11 seconds. And time for which the mechanical energy becomes the half of its initial value. So tau half is equal to 5.5 seconds. That is the answer of extra numerical. Again, M is equal to 400, K is equal to 120, and B is equal to 50 gram per second. Calculate yourself for practice. Okay, now one more extra numerical. Already that is the same as earlier our last illustration numerical. Right? What is given? An oscillator of mass m is equal to 100 gram perform damped oscillation. When it completes the 100 oscillation, its amplitude becomes the half of its initial or the original amplitude. If the time period is 2 seconds, then find the value of damping coefficient. Here we have to find out the damping coefficient. Here directly time interval is not given. For this time, its amplitude becomes the half of its original value. But instead of this, after the 100 oscillation, its amplitude becomes the half is given. Therefore, first we have to find out the time for 100 oscillation, in which time its amplitude becomes the half of its original value. First, what is given? The mass m is given. That is the 100 gram. That means the 0.1 kg. 0.1 kg. Right? Periodic time t is given the 2 seconds. 2 seconds. We have to find out the damping coefficient. Periodic time t is equal to 2 seconds. That means time for one oscillation. Or the one oscillation takes place in 2 seconds. Therefore, for one oscillation, time t is equal to 2 seconds. Therefore, for 100 oscillation, time t is equal to 2 into 100. That means the 200 seconds. Now, amplitude of damped oscillation is T is equal to E is to minus Bp upon 2M. Minus Bp upon 2M. Now we find out the time t in which the amplitude becomes the half of its original value. For t is equal to 200 seconds, when t is equal to 200 seconds, a dash t becomes the a by 2. Clear? Therefore, a by 2 is equal to a is to minus bt upon 2n. A cancel. Therefore, directly compare 2 is equal to a is to bt upon 2n. Take ln on both sides. Take ln on both sides. Therefore, ln2 is equal to only bt upon 2m. They require the b. Therefore, b is equal to 2m ln 2 upon t. Now, 2. M is 0.1. ln 2 2.303 log 2 upon time t 200. So as we substitute the log 2.3010, we obtain the answer is 0.693 seconds. 0.693 seconds. So very easy numerical, but here directly there is not asked find the time for, the amplitude becomes the half of its initial value. Instead of this, quite differ. Here we have to find out the damping coefficient after the 100 oscillation. Because after the 100 oscillation, the amplitude becomes the half of its original value. Here the periodic time given. Periodic time, that means the time taken by the oscillator to complete the one oscillation. And due to that reason, for one oscillation, time taken is 2 seconds. Therefore, how many oscillations are given? There is 100 oscillation. Therefore, 100 oscillation time t is equal to 200 seconds. So in 200 seconds, the amplitude becomes the half of its original value. Now, amplitude of damped oscillation, A dash t is equal to A is to minus bt upon 2m. In t is equal to 200 seconds, the amplitude A dash t becomes the half of original value A by 2. Substituted in this equation, therefore A by 2 is equal to A is to minus bt upon 2m. A cancel. Here power is negative, therefore 1 by 2 is equal to 1 upon A is to bt upon 2m. Comparing denominator term only, therefore 2 is equal to A is to bt upon 2m. Now take ln on both sides, therefore ln 2 is equal to bt upon 2m. We require the value of b, therefore b is equal to 2m ln 2 upon t. Clear? Now ln 2 is equal to 2.303 into log 2. So 2.303.3010. So value of the log 2 is 0.3010. As we substitute, we obtain the 0.6937. Clear? Okay. Now in exercise, first we calculate the 14.9 numerical of exercise. Already the same numerical we calculate in illustration. What is given? A spring with the spring constant 1200 Newton per meter is mounted on a horizontal table as shown in the figure. The one end of the spring is connected with the rigid support and other is connected with a body of mass m is equal to 3 kg. The mass is then pulled sideways to a distance of 2 cm. That is, the x is equal to 0. Now the body is pulled by x is equal to 2 cm and released. So what's happened? The body performed the simple harmonic motion about the mean position. So in this situation, we have to calculate the frequency of oscillation F. Second, maximum acceleration A, and third is maximum speed of mass. So first, what is given in this numerical? Here the first constant K is given 1200 Newton per meter. Spring constant. Here the mass of a body m is given. That is the 3 kg. 3 kg. Only two values are given. We have to calculate first the frequency of oscillation. First is frequency of oscillation. Now we know the periodic time of a spring T is equal to 2 pi under root of m upon k. We know that the frequency is equal to 1 upon t. Therefore, 1 upon 2 pi under root of m upon k is equal to 1 upon 2 pi under root of k upon m. That is the equation of frequency. Clear? So directly we have this equation of frequency. F is equal to 1 upon 2 pi under root of k upon m. All values are given. Now listen. 1 upon 2 pi is 3.14 under root of k 200 by 3, 1200 by 3. Therefore 1 upon 6.28 and square root of 400 is equal to 20 upon 6.28. 20 upon 6.28 we obtain. Therefore, its numerical value is 3.18. So 3.18 second inverse. That is the frequency of oscillation. Now the second part, we have to find out the maximum oscillation. Maximum oscillation. Oscillation is oscillation of simple harmonic oscillator is A is equal to minus omega square x. Now the oscillation is maximum at the extreme point x is equal to plus or minus A. Right? Therefore, for maximum oscillation, x is equal to plus or minus A. Therefore, A maximum is equal to omega square A. Omega square. Now, what is the value of omega? We know that K is equal to m omega square. K is equal to m omega square. Therefore, omega square is equal to K upon m. Therefore, K upon m into a. K is given 1200 upon mass is given to 3 kg. 3 kg. Right? And also, what is the acceleration? The acceleration is given the 2 centimeter, that means the 0.2 meter. So it's equal to 8 meter per second square. 8 meter per second square. Here, there is the maximum value of acceleration. Now, third, what is the maximum speed? Maximum speed. So we know that the direct equation of maximum speed, V maximum is equal to A into omega. A into omega. Here we substitute the value of omega. A into under root of E upon A. So from this equation, omega square is equal to K upon M. Therefore, omega is equal to under root of K upon M. Now, amplitude is 0.2. Here, K is 1200 upon 3. So there is the 0.2 into 20. 0.2 into 20. So is equal to 4 meter per second square. 4 meter per second square. Meter per second square. So that is the answer of the maximum speed. And here the maximum speed of the oscillator is at the mean position. When it executes the simple harmonic motion, when it passes to the mean position, at the time the speed is maximum, and at extreme point its speed is minimum and acceleration is maximum. So directly we have to substitute the value of the given quantity in given equation. So here the frequency of oscillation f is equal to 1/2 pi under root of K upon m. If we substitute 1/2 pi 3.14 under root of 1200 upon 3. So there is the 400, right? Square root of 400 is 20. So 20 by 6.28, we obtain the frequency is 3.18 second inverse. Now the maximum oscillation. First, the oscillation of simple harmonic oscillator is A is equal to minus omega square x, and at the extreme point its oscillation is maximum. Therefore, for maximum A, x is equal to plus or minus A. Therefore, A maximum is equal to omega square A. Omega square is K by M into A. K is 1200 by 3. 400 into 0.2. 400 into 0.2. So we obtain the 8 meter per second square. Now the maximum speed is, we know the equation of the maximum speed, V maximum is equal to A into omega. Therefore, A into under root of K upon M. A is 0.2, under root of 1200 by 3, therefore under root of 400. Now the square root of 400 is 20. Right? Therefore is equal to 4 meter per second square. That is the maximum 4 meter per second image. Clear this? So this type of the numerical may be asked in simple harmonic motion or the oscillation. Clear? Okay.